Every year, millions of tons of plastic waste are discarded across the world. Inside this advanced recycling facility, discarded PET bottles and plastic packaging begin a transformation into ultra-soft synthetic textile fibers used in premium ladies' underwear manufacturing. What you're about to witness is one of the most advanced recycling transformations ever created inside a futuristic mega-factory. Stay till the end to see how millions of waste bottles are reborn into ultra-soft fashion fabrics. You love seeing futuristic factories, giant machines, and unbelievable manufacturing processes. Subscribe to Factory Scenes and turn on notifications for more cinematic industrial transformations every week. Optical sorting technology uses near-infrared spectroscopy to identify polymer types within milliseconds. AI-controlled air jets separate recyclable PET plastics with remarkable accuracy. Processing begins. Industrial pre-washing systems remove dirt, labels, adhesives, and organic contaminants using heated water and rotating agitation chambers. Cleaned plastics are mechanically shredded into uniform flakes, increasing surface area for efficient purification and melting during later textile processing stages. Fructpun washers use high rotational forces to eliminate residual oils, glue, and fine contaminants that could weaken textile fiber quality. Dunsata separation technology isolates PET plastics based on specific gravity differences, ensuring only high-quality recyclable material enters fiber production. Removal is essential because even microscopic water content can damage polymer chains during melting and fiber extrusion. These purified flakes are precisely metered into extrusion systems where controlled heat converts solid plastics into molten polymer. Inside the extruder, precision-controlled temperatures melt PET flakes into a highly viscous polymer. Advanced melt filtration systems eliminate microscopic particles that could weaken textile strength or create imperfections in fabric production. This molten polymer is forced through spinnerets containing hundreds of microscopic holes, creating continuous synthetic filaments similar to silk threads. Contralu cooling stabilizes the molecular structure of the synthetic fibers, giving them durability and elasticity required for intimate apparel fabrics. Stretchung aligns polymer molecules along the fiber axis, dramatically improving tensile strength, flexibility, and softness. Krumpung creates tiny waves in the fibers, improving softness, insulation, and fabric comfort for wearable textiles. Continua's synthetic filaments are cut into staple lengths that can be spun into yarn suitable for breathable underwear fabrics. Rusaclo polyester fibers are blended with elasting to create stretchable fabrics capable of maintaining shape and comfort. Cutting machines align tangled fibers into uniform webs, improving consistency before yarn spinning begins. Drung frames straighten and blend fibers further, ensuring yarn uniformity and structural balance. Rung spinning twists aligned fibers into strong yarn, suitable for high-performance lingerie textiles. Precision winding systems prepare the yarn for large-scale knitting operations while maintaining even tension. LUSA inspection systems identify microscopic defects that could affect comfort, elasticity, or durability in finished garments. Computer control dye systems formulate precise colors while minimizing water and chemical waste. Hupreshka dyeing technology bonds pigments directly to polyester molecules for long-lasting color retention. Tumperpsh control drying systems preserve yarn elasticity while removing residual moisture after dyeing. Knitting technology produces seamless stretch fabrics ideal for modern underwear manufacturing. Spasoilazed elastic weaving systems create flexible waistbands designed for comfort, recovery, and durability. Optical inspection systems detect weaving flaws, dye inconsistencies, and structural imperfections before garment cutting begins. Fabric relaxation stabilizes tension within knitted materials, preventing distortion during cutting and sewing operations. Computerized pattern systems maximize material efficiency while maintaining precision dimensions for every garment component. Automated CNC cutting systems produce identical fabric pieces with millimeter-level accuracy. Ultrasonic sealing prevents fraying while creating smooth edges that improve wearer comfort. Gusset layers improve moisture control and comfort in intimate apparel design. Bonding technology creates smooth, low-profile seams that reduce skin irritation and improve flexibility. Elastoc attachment systems balance tension and flexibility to ensure long-lasting garment shape retention. Automated sewing systems ensure uniform stitching strength while reducing material waste and production defects. Decorative lace components are integrated using precision stitching techniques that preserve elasticity and softness. Hut transfer branding systems create durable labels without adding uncomfortable stitched tags. Automated trimming systems remove excess threads, ensuring clean, premium quality garment finishing. Mustiawakung technology allows synthetic fibers to transport perspiration away from the skin for enhanced comfort. Stum softening improves tactile comfort while relaxing textile fibers for a smoother feel. Ultraviolet sterilization systems eliminate microorganisms before packaging, ensuring hygienic textile processing. Robotic folding systems maintain product consistency while preparing garments for automated packaging. What happens inside the next machine is absolutely mind-blowing. This next process determines whether the fabric becomes premium quality or complete waste. Watch closely as molten plastic turns into microscopic textile fibers. The final product is almost impossible to believe. This is where recycled plastic begins to feel softer than cotton. The next stage uses futuristic textile technology most people have never seen before. You won't believe how these machines create seamless underwear at incredible speed. With us, the final reveal shows the complete transformation. The ending proves how advanced recycling is changing the future of fashion forever. Waste to wearable innovation. Recycled textiles deliver softness, durability, flexibility, and sustainability without compromising quality or design. Unjanad elasting blends provide multi-directional stretch and long-term recovery performance. Regulation testing evaluates how engineered fabrics manage body heat during daily wear. Assisted packaging protects textile quality during transportation and storage. provide inventory control and complete production traceability. Controlled warehouses manage inventory movement using autonomous logistics systems. Precision weight verification ensures packaging consistency and identifies incomplete product sets. Industrial robotics accelerate packaging efficiency while minimizing handling contamination. Automated logistics vehicles streamline internal transportation and improve operational
Proceeding with
efficiency.
the underwear pallets.
Funashed products are prepared for global distribution through advanced logistics systems. From discarded waste to wearable fashion, recycled textile products now travel worldwide through sustainable supply chains. What began as discarded waste plastic has now become high-quality performance apparel designed for comfort, flexibility, and sustainability. Advansu Textile engineering transforms recycled polymer into soft, breathable microfibers suitable for premium intimate apparel. Recycled fiber reduces landfill waste and conserves raw petroleum resources used in virgin plastic production. Inside the heart of advanced recycling technology, waste plastics are reborn as premium wearable textiles, proving that innovation and sustainability can reshape the future of fashion. This is the future of sustainable manufacturing. Thanks for watching Factory Scenes. Until the next factory journey, keep exploring the machines shaping tomorrow.